Thank you, James. Thank you, Digital Orientalist, for giving me this platform to share my research work. What I'm going to present is a test that I did on geospatial mapping using LLM. If we can use LLM to assist in geospatial mapping. And so my name is Prince Kumar, and I am studying at Université de Franche-Comté, and I am doing my master's in rare book and digital humanities. And what I'm going to present, like Ines, is part of my master's research project. It's not exactly my thesis, but something I did, something I tested in order to get the results for my thesis. So, what I was trying to do is I wanted to do a comparative study of English and French travel writings, and I wanted to use some digital methods to do the analysis. And the period that I chose to do the analysis is 17th century, and I chose that period primarily because there are a lot of regions. It was a very important period in the history of the three nations involved in this, three regions, three nations involved in this study. So, for example, in France, it was Louis XIV, who came to power during the 17th century. Then in England, there was the Civil War, and King Charles was executed. So there was a lot going on during that period. But primary reason for choosing 17th century is because the French, they started coming to India by 17th century. Vasco da Gama discovered the route, the direct maritime route to India in 1498. But wait, in 1498, but French, I for some reason they were very late and they started coming in 17th century. So this is the earliest period to do a comparative analysis on the travel writings of English and French. And so by this time, there was already a lot of advancement in maritime technology, and so there was a lot of uh, visitors, voyagers coming into India. Uh, some names I have mentioned here: William Hawkins, Thomas Roe, François Bernier, so many. And because there are so many writings, I needed some digital technology, digital means to do it, some way of distant reading this all this material, because the corpus becomes so huge. Some of these writings are just letters published in the form in collected volumes of Samuel Purchas. Others are like large multi-volume editions. So ultimately, the corpus is very huge. So I needed a method, uh, digital method to do all of that, and the one of the major part of the project was to create a digital cartography, digital map of the routes that these voyagers took from Europe to India, and so make a digital map out of it. And so the major thing that I was trying to test is if LLM, which is capable of doing, which at least promises or at least to do all kind of uh, analysis, all kind of filtering on the large amount of data and give you results without going into too much details. Last summer I was at Ghent University, the Department of Digital Humanities of Ghent University, and they are working on a project which is called CLS Infra, and so I was part of it. I worked on it for some time. So they are basically making a pipeline, an automated pipeline for doing all kinds of analysis, digital humanities analysis, like named entity recognition, sentiment analysis, relationship extraction. And they have created notebooks, which well documented notebooks, which can be used by people in the humanities, who do not have very great technical knowledge to navigate the complexities of digital tools. So they made this notebooks to be used for such kind of analysis. And in the in the same project, they are also uh, kind of testing LLMs or AI for these kind of analyses and how fair they perform. So that was my motivation. So to do this digital mapping directly from the corpus, directly from text, there are a lot of steps involved. And so to do it efficiently, there are a lot of complexities as well involved to navigate, to process this text. So, for example, at the level of OCR, so because these 17th century texts, 17th century documents, they have old prints, they have old fonts, they, I mean, a lot of people in previous presentations also talked about it. So they need to very correctly process and detect these texts. And so the earlier models based on character recognition, they just try to identify the shape of the printed text, and they corresponded to a letter. But these AI models, they use some semantic understanding to do the OCR, so they may perform well. So there are many problems which an LLM or any pipeline that we will apply for this kind of analysis. So the first, as I said, is OCR. At the level of OCR, there is prints for fonts, and sometimes the pages are torn apart, mm, ink bleeding, a lot of problems. And then also we have the problem of layout detection. For example, I have in this page here, this is an edited volume, so it was printed later in the 1904, but the journal itself was written in the 17th century. So in this edited volume, you can see there is a kind of a footnote given by the editors. So when we do the analysis, we don't need to consider these. We just need the main text written by the the author, the voyager himself. And at the level of linguistics also, there is, since 18th, 17th, 18th century, it's been 200 years from now, the language has evolved. The translation, there is a problem of translation, spelling variations, and there is also the problem of when we are dealing with texts, there problem of implicit references, narrative noises. I mean, Ines talked about these things in his presentation as well, and they are something to deal with when you do some kind of these kind of analysis. And thirdly, there is also the problem of toponyms. So, for example, here you can see uh, the author has used the word Madras for a region which we don't call it anymore. The names have changed, so we have to take that as well into account while doing such kind of analysis. So I so the idea was to try if LLM can do this kind of analysis by itself without any human input, without any verification kind of thing. And so I tested it, and because LLMs have kind of very capable they are, and they have, at least they promise to be very very good with unstructured textual data. So they can also they have multimodal capabilities, so they can directly take PDFs or images as input and process them, so we don't need to give them just text. We can provide them PDF and images, and they should work just as fine. And they have, as I talked about this semantic understanding, they can do OCR based on semantic understanding rather than character recognition. So they produce better results for OCR because sometimes in, at least in 17th century French documents, you see S, which looks like F, but it is actually S. So that can change the meaning of the whole sentence. So that kind of thing we need to take into consideration. The references, implicit references, multilingual corpora that I'm dealing with, and I talked about the historical names, the names that have changed over time, toponyms. So all of these LLM should be able to handle very well. So to do the kind of mapping that I'm trying to do in traditional workflow, you Ines in his presentation also pointed some kind of this kind of a workflow needed in a traditional workflow, and so it involves a lot of intermediary steps, discrete steps, and each step has its own uh, uh, technical details that we have to go into while doing our research, things that we have to consider. So each of these steps that I have mentioned here, they have their own technical and ethical considerations. So in a traditional workflow, we first will either take a PDF or an image. Usually it's PDF, and then PDF needs to be converted into images, and you can use this library to do that. And then that image needs to be converted into text. So we need OCR, or in some cases HDR also, and these are the tools that we use generally. Like keynote speaker talked about is scriptorium and transcribers in his presentation, and then we need NER to identify the names of the places, and for that we need some kind of NLP technology. These are some of the prominent ones that we use these days. And then those NERs has to be correspondent with the gazetteer to find the actual names, the because historical names, because of the historical names. So by this World Historical Gazetteer, Getty, these are all the gazetteers we can use. And then once we have the names, we can convert those names into geocodes, with the help of these geocoding libraries, and then those geocodes could be plotted on a map with a QGIS, ArcGIS, anything. So it's a lot of steps, and but it is not very difficult to do, but could be difficult for some people. So in an LLM assisted workflow, all these steps from PDF to geocoding can be replaced by an LLM. And once we have the geocode, we can map it, we can plot it on a map. And it's as simple as that. It should be at least as simple as that. So I tried to test this hypothesis with Jupyter. I created a Jupyter notebook and I used Gemini API and Google's Gemini 2.0 Flash, which is their latest model, to do this analysis. And I tested it on two 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 texts. So I did not provide the full full document, but just one chapter each of these, one in English, another in French, written by Peter Mundi. This one published in 1904, this one by François Pirard and published in 1611. So this is the prompt that I gave to Gemini, and so here you can see I am mentioning that you are a name entity recognizer for printed for 17th century documents. So I am specifying it what it needs to do, and then I am also telling it to do the things step by step. So I first tell it to identify the name of places, then correspond it to their actual names, do not consider the footnotes, and also for the and then yeah, for them, then geo coordinate, then coordinate them to geo coordinates. And for the dates, I ask it to convert the dates could be written in any format in the text, but I ask it to change it into this format, which would be easier for further analysis for mapping. And so here are the results that I got for the two books, for the two, not the books, actually, just the chapters. And as you can see, this is pretty good. It seems about right in both the cases. Just a few cases of going backtracking. So here we can see it is going back to this point and then coming back because it was referenced later in the this point was referenced later in the book, but overall it does a pretty good job. And I think with a little bit of refinement, it can produce the desired results. But of course there are limitations to this. First of all, as most a lot of people before me talked about it, AI hallucination, AI biases, all of that, which are inherently fed into AI models, which they exist, so they are something to be taken into considerations, especially when we are doing uh, or analysis on Oriental studies, colonial or post-colonial studies. So that is something to be taken into consideration. Other technical challenges are like not all LLMs are multimodal, so then in that cases you need to convert the document into text first to be fed into LLM. And so because the LLMs have an limit on how big the input can be, so for example large editions, they cannot be used for this purpose. And the solution for this is to chunk the text into small sections, like I took only first chapters of the text. But again, in that case, there is a risk of context loss. And since I tested with 17th century documents, they are old but not that old, so maybe for texts which are older than 17th century they might not work, because uh, LLMs or AI, they are not specialized in handwritten text recognition or OCR, so they will not work for very old text. And then there is the problem of black box. So when we do all of this in one step, we are kind of creating a black box where we just give the input and we get the output. We don't know what's going on inside what AI is doing. AI already is a black box, but giving all of these things in one go, trying to make all of things do in one go, is just enhancing that black box further. So to conclude, what I think from my testing is that this single workflow is possible, but I don't think it would be recommended for serious research work. So instead, we can use LLMs for this kind of analysis, but use it one step at a time. So, for example, first you give the text as give the document as your input and get out the text as output, and then give that text as the input, and then do NER on them and so on. So one step at a time. And we can also use the traditional methods for most of the steps, but use LLM for some certain steps only. For example, named entity recognition, which is the most challenging aspect of this whole analysis. So we can use LLM for that part only, and others we leave it to traditional methods. And for other And also, yeah, I noted that if we do discrete steps with LLM, that produces better results instead of do trying to do everything one in one go. So that's something to consider in mind. And the and yes, there are specialized models for, instead of using a general purpose large model like Gemini or ChatGPT. There are several specialized models which are available on Hugging Face. So use we can use those specialized model at each step, and that would give a better result. So I think that's it for me.